Good afternoon to my dear children. How are you? All are fine? Okay. Many of them wrote the correct assignment with also the problem, and also you correct your assignment and also get your signature from your parents. I appreciate you all for the 11th standard, and day by day all of you do like this. But few of them are not submitted your assignment, and daily I am watching. Okay. Today our learning portion, the shape of the atomic orbital. Shape of the atomic orbital. This is our today learning objectives. Here, a few of them ask about the doubt. What is about the orbit and what is about the orbital? What's the difference? Somebody has asked me. So again I am telling, what is an orbit and what is an orbital? Orbit means it refers to shell. That means a K shell, a L shell, M shell, N shell, etc. As per 2n square formula, we are accommodating the electron in a various shell. That is about the orbit. We can do that one. And about the orbital, it explains about the subshell. That is S subshell, P subshell, D subshell and F subshell, etc. That also we already done. Today also we are discussing that orbital. Okay, anyhow, about the orbital. The orbital is the three-dimensional space. It is a three-dimensional space in which the probability of finding the electron is maximum. That means, and electrons are revolving in a particular area. We are viewing by three-dimensional. How the electrons are moving, that we are going to discuss now. First of all, we are discussing orbit, that is shell. Okay, please all of you take your note, and we can do how the electrons are occupying. Just a few examples. Okay. The differences will be shell and subshell. That means orbit and orbital. Orbit and orbital. It refers to shell. There are K shell, L shell, M shell, N shell, O shell, etc. Okay. Here K shell we can be accommodated as per the 2n square formula. 2n square formula. N square formula. For n is equal to 1, it refers to first shell or K shell, first orbit. Okay. If you are applying n is equal to 1 means 2 into 1 square. 1 square is equal to 2. So K we can be accommodate 2 electrons. Clear? 2 electrons. N is equal to second orbit. That is n is equal to 2. N is equal to second orbit, n is equal to 2. We are applying this formula here. So what's the answer? 2 into 2 square. 2 into 2 square is equal to 2 into 4 is equal to 8. So L shell we can be accommodate 8 electrons. Clear? Next about the M shell. N is equal to 3. That is third orbit. M shell. That is 2 into 3 square. 3 square means 9. 2 into 9 is equal to 18. So here we can accommodate 18 electrons. Next, fourth shell, fourth orbit. N is equal to 4. That means 2 into 4 square. 2 into 4. 4 square means 16. 2 into 16 is equal to 32. Am I right? 32 electrons. Next one. fifth orbit, fifth shell, O shell. N is equal to 5. 2 into 5 square is equal to 2 into 25 is equal to 50 electrons. These are all orbit, shell. It denotes the shell. Next about the orbital. Orbital. That means a subshell. Denotes the subshell. A subshell. Yes, we can accommodate 2 electrons. One s orbital, 2s orbital, 3s orbital, like that. Okay, 1s, 1s. The maximum we can be accommodate. First, we can be accommodate 1 electron. This is the minimum. Okay. What's the maximum means? We can accommodate 2. The spin, one is upwards, one is downwards. It is a paired electrons. Paired electrons. Clear? Clear. It's a 1s. Maximum we can accommodate how much electrons in a subshell? 2 electrons. 2 electrons. Okay. Then about the p subshell. Here the p subshell we can accommodate it. The maximum is how much? Maximum 6 electron maximum. Okay. That means this is the p subshell. 2px, 2py, 2pz. 2px, 2py, 2pz. Clear? That means in each orbital we can be accommodate 2 electrons. Okay. First start with singly. 1. For example, total electron is 6. Am I right? 1, 2, 3, 4. That only pair. 5, 6. So like that, p subshell we can accommodate 6 electrons. Can you like 1s, 2s, like that. 3s like that. Okay? This also, suppose for example, helium is helium. Atomic number is 2. So 2 means we can accommodate 2 electrons for 1s. These are the examples. And also have a lot of theory. After the, I think that these are the unit last of this topic having about this. How can you accommodate the electron in subshell? Next about the d subshell. D is equal to having 5 orbitals. 1, 2, 3, 4, 5. That is d, x, y. D x z, d y z, d x square minus y square, d z square. These are the 5 orientation here. In each, we can be accommodate 2 electrons. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We can be accommodate the maximum number of electrons is 10. Here the maximum is 6 for P. Yes, the maximum is 2. Here, like that F. How can you calculate? How can you draw the F subshell? F we can accommodate 14 electrons. How many electrons? 14 electrons. One, 2, 3, 4, 5, 6, 7. Here each one carry we can be accommodate 2 electrons. Okay, each one we can carry 2 electrons. Okay. First of all, you should be say the orbital. First one is F Z Q. Okay, can you say what is the first one? F Z Q. Second one F X Z square. What is the second one? F X Z square. Next one F Y Z square. Third one F Y Z square. Next one F X Y Z. Okay, F X Y Z. Next one F Z X square minus Y square. Here f is x square minus y square. Next about f x square minus 3y square. Here, it's the sixth one. First one, f z cube, f x square z, f y z square, f x y z, f z x square minus y square, f x square minus 3y square. Next about last one, f y 3x square minus y square. Okay, f y 3x square minus y square. These are the orientations of f orbitals. Okay, can you say about the s option? This one is having only one. About the p, what are the p? 2px, 2py and 2pz. What are the p option? 2px, 2py, 2pz. We can be accommodated 6 electrons. And also the d option. These are the 5 orientation. D xy, d xz, d yz, d x square minus y square, d z square. Like that, f you can accommodate how much electrons? 14. That is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Which are the orbital? Tell me. F x cube, sorry, f z cube, f x square, f x z square, f y z square, f x y z, f z x square minus y square, f x square minus 3y square, f y 3x square minus y square. These are the orbitals on f option. Okay, these are about the orbitals, and previously discussed about the orbit. Previously discussed about the orbit. We can be explained by above. Schrödinger wave equation gives the parameter total energy value is called eigenvalue, and the wave function correspond to the eigenvalues are called atomic orbitals. Okay, here the atomic orbital definition is coming. Okay, for example, how can we prove this one? How can we explain this one? We are taking one electron system like hydrogen can be represented in spherical polar coordinates. We are taking coordinates, that is the coordinate variables such as r, theta and phi. Which are the variables are taking? R, theta, phi. Okay, not psi. We are using phi. Okay, here psi into r theta phi is equal to r of r, f of theta and g of phi. Here r of r is called radial wave function. What is r of r? R of r is called what? Radial wave function. The remaining two functions, which are the remaining two functions, f of theta and g of pi are remaining, the two functions are called as angular wave function. Okay, this is explained by Schrödinger wave equation. Next about radial distribution function. Radial distribution function. It is the based on the radius. For example, the center of the atom to the outermost shell. That we are taking the radius r, small r, radius r, the center of the nucleus to the outermost shell. Consider a single atom of hydrogen in the ground state. Here the principal quantum number n is equal to 1 and the azimuthal quantum number n is equal to 0. Already I told you that the principal quantum number symbol is n and the azimuthal quantum number, the symbol is l. Here principal quantum number n is equal to 1 and azimuthal quantum number l is equal to 0. That is, it is in oneness orbital. Which orbital? Oneness orbital. When we plot the graph, the probability of finding the electron as r, that we are taking capital R. Okay, capital R, r square. Capital R into r square in y-axis. We are plotting in the form of graph. We are taking for the graph having y-axis and the z-axis. Am I right? In the x-axis and the y-axis. Here, y-axis we are taking capital R into r square in y-axis and also the radius r in the x-axis. Now, what is about the slope in the graph? Let us we can be discussed in the board. How can you draw the graph between? I told you about that the probability of finding the electron versus distance. Imagine this is one of the graphs we are plotting with x-axis. We are taking the radius r, okay, and also in the y-axis we are taking the probability of finding the electron. Probability of finding the electron. Probability of finding the electron, that is we are taking r, okay. These are the two variables we are taking, r square, okay. These are the variables. As per here we are making here 0, as per the 0. Next we are taking 5, 10, 15. In the x-axis and also y-axis about 0 here, 0, 2, 0.2. Next about 0.4. Next about 0.6. 0.8 like that. Okay. We get a graph like that, one of the small slope curve like that, one of the curve. Here, what is about this curve means, this graph shows that the distance between the electron and the nucleus decreases. Listen, one of the hydrogen atom, center of is nucleus, this is an outermost shell, okay, maybe hydrogen atom, and one of electrons, okay, one of the hydrogen atom electrons. Here the distance between the center of the nucleus, here, center of the nucleus and the electron distance means here we are seeing r, is decreases. The probability of finding the electron is increases. What's the condition here? Explain about this graph means, in this graph shows that the distance between the center of the nucleus and the electron, the distance is decreases. The maximum probability of finding the electron is increases. Here, okay. Here r is, when r is equal to 0, the quantity of r square is maximum. Here r is equal to 0, the radius r is equal to 0. Here what is the r square is what? Maximum. This is about the graph. Next about, we can be, how can you consider the volume of hydrogen, okay, dV, that means dV calculation, okay, volume, that is volume calculated, okay, that is, it is bounded by two spheres. We are taking a two sphere of radii r. Two sphere we are taking. This is one of the nucleus. This is another one. One of the sphere. Here, the distance between the center of the nucleus and the outermost electrons means we can be taken as r. Okay, here we are using what? The radius is r. The distance is r, and this is the distance. This distance we are saying that this distance is about the dr. What's the distance? Dr. That means here we are taking total. We are taking means r plus dr. Okay, r plus dr. Here. So, how can you measure the volume of the sphere? How can we measure the volume of the sphere? Here, this is bounded by two spheres of radii r, and
two sphere. One is the radii R, one sphere, and another one sphere is R plus dr. R plus dr. Here, the two sphere. How can you measure the volume of the sphere? Okay. Here the volume of the sphere is equal to, all of you know that one. Volume V is equal to 4 pi 3 pi R cube. Am I right? The volume V is equal to 4 pi 3 pi R cube. This is the formula. Volume of the sphere. Volume of the sphere. What is the formula? Volume V is equal to 4 by 3 pi R cube. Volume of the sphere is equal to 4 by 3 pi R cube. This is the formula. Next we are differentiating. Differentiating dV with respect to R. Okay. Differentiating dV with respect to R. Okay, with respect to R, we are using one formula. That is the formula is dr cube is equal to, one of the formula is, that is 3R 3 minus 1. Okay, so what is that one? 3R square. What's the answer? 3R square. So this can be written as dV by dr is equal to 4 by 3 pi 3R square. Okay, right? 3R square. Can you write? Here we are taking dV. dV is equal to, here we are cancelling, 3 cancelling. So what is answer? What's the answer? dV is equal to 4 pi R square dr. Okay. dV is equal to 4 pi square into dr. Okay, into dr. And also we are multiplying this equation by psi, our wave function. Okay, multiply this equation by psi, wave function. That is psi square dV equal to 4 pi R square psi square dr. This is the equation. Okay. This is the equation. We get, and these two variables we are taking. One is radius, and another one is 4 pi square, 4 pi R square, pi square dr. We are against plot against versus to R. We get one of the slope. What is that slope means? What is the slope means? We are plotting two variables. That is the x-axis we are taking radius in Armstrong unit. Okay, radius. Here we are taking 4 pi R square pi square. Okay, these are the two variables, and 1, 2, 3, 4, 5, 6. Here we are taking 0.1, 0.2, 0.3, 0.4, 0.5. Okay, here one of the slope is obtained from the 0. That is one of the peak. Okay, in between the range is 0.5 we get. Here the above plot show the maximum probability occur where the maximum probability occur in 0.5. Where the maximum probability occur, and the 0.5 okay occurs the distance about the 0.5 Armstrong unit. 0.5 to Armstrong unit. Okay, because the value is here 1, in middle the value is 0.5. We get the 0.5 about the maximum probability occur the distance from the nucleus. This is equal to, this value is equal to Bohr radius. bow radius. Okay. Next we can be discuss about the radial distribution function. Radial distribution function of 2s, 3s orbital. Okay. Just you draw the graphical method for you, okay? Here the radial distribution of 2s, 3s, 3p, 3d orbitals for hydrogen atom. Okay? The radial distribution, okay? The radial distribution. The radial distribution of 2s orbital, 3s orbital, 3p orbital and 3d orbital. Here we are plotting one of the graph. Graph versus radius. That is the unit of bow radius. Okay, radius, and also we are taking 4 pi r square, pi square. Okay. Here for the 2s orbital, this is for 2s orbital. We get this is here. We are starting here. We are giving the values, that is 0, starting 0, 5, 10, 15, 20. 20 we are giving, and also 0.05, 0.1. First one of the slope is start here. This is the maximum probability of electron there. Okay, here where, for example, this is 1s, next is a 2s. This is 1s orbital. Here is the 2s orbital. Here, this area we are telling that a radial node, otherwise called nodal surface. A radial node, or otherwise called what? Nodal surface. This is the we learn only the graphical representation of radial node for this 2s orbital. Okay, can you draw this one? This is for 1s, this is for 2s. Okay. Next about Three orbital. One of the graphical representation for 3s orbital. Same in the x-axis we are taking r. And y-axis the same only we are taking 4 pi r square and psi square. Okay. The same units we are giving for x-axis 0, 5, 10, 15, 20, 25. Here about the same value we are giving 0.05, 0.1 the value. Here the starting is here, starting is 0. First increasing, next decreasing, next increasing, next decreasing, next again increasing, next again come to 0. This is the maximum. Okay. Okay. Here first starting is 0, next slightly increasing, next decreasing the slope, next again increasing, next again decreasing, next again increasing, and then again decreasing. Here this is the 3s. Okay. 3s, this is which s? 2s, this is 1s. Okay. This is the graph here. For the 2s orbital, the distance from the nucleus first, r is increases. Here the distance from the nucleus from r is increases, then probability density first increases. Okay. The probability density first increases to reaches the maximum. Then again decreases to comes to 0. and then increases, and other comes to maximum. This is maximum. Then again decreases. Then again increases. This comes to maximum. Then again decreases and comes to 0. Decrease to 0. This region, the region where the probability density function reduced to 0 is called nodal surface. Reduced to 0, this 0 is called what? Nodal surface. Otherwise we are saying that radial node. Nodal surface otherwise called radial node. And also it have one of the formula. What is the formula means? For the ns orbital, it has one formula that is n minus 1 node. What's the formula? For the ns orbital, there is one formula n minus 1 node. Okay. Next about again we have the 3p orbitals. Next we can try about that 3p and 3d orbital. 3p and 3d orbital. Okay, 3p and 3d orbital. Here we are plotting the variables. Thus r and 4 pi r square and psi square, and the values start from 0, 1 and 5, 10, 15, 20, etc. Here 0.05, 0.1. Okay, and here the slope is start from 0. This slightly increases, then the maximum probability after that it will be decreases, then it again increases, and again decreases. This is for 3p. Like that about the 3d, same also 3d. This is about the 2p, okay? This is about the 2p, this is 3p. About the 3d, versus r in the x-axis and also y-axis 4 pi r square psi square. Okay, start with the same unit 1, 0, 5, 10, 15, 20. Okay, 15, 20. Here also 0.05, 0.1. Okay, here the slope is start with here 0, then only increases, then again decreases and become less value. Okay, this is about the 3D. Clear? 3D only starting. Okay, here about one of the formula. What is about the formula means the plotting 4 pi r square 5 psi square versus r for the 3D and 3p and 3d orbital shows similar pattern. Okay, but the number of radial nodes are equal to n minus l minus 1. This is the formula. What is the formula for 3p and 3d? This is for the one word 3p and 3d. Here the formula is n minus l minus 1. All of you know that one. What is n? The principal quantum number. And what is l? The azimuthal quantum number. Okay. This is about the graphical representation. This is just you read that one. This is only for the one word. And next about the angular distribution function. Angular distribution function. The variation of the probability of locating the electron on the sphere with the nucleus, its center depends upon azimuthal quantum numbers. Okay, it centers depends upon what? Azimuthal quantum numbers. Here, for an 1s orbital, the value of 1s orbital, the value of L is equal to 0 and M is equal to 0. Okay, and also f of theta is equal to, this is the important value, f of theta is equal to 1 by root 2. Okay, 1 by root 2, and also g of phi, okay, is equal to 1 by root 2 pi. Here the diagram, what is the diagram is, for example, this is the hydrogen atom, the nucleus, the center is nucleus, this is an x-axis and this is the y-axis, am I right? This is an z, x, y, z. Here we are giving, this is the, for example, hydrogen atom, the one of an atom is locating on the center, okay? Here we are giving the radius r, the distance between the electron and the nucleus. The distance between the electron and the nucleus, we are giving the distance r. Okay. Here we are giving one of an angle called theta. Which angle we are giving? Angle we are giving theta. Here we are giving is called psi. Okay. When you are looking, it will be comes this side. This side it will be phi. Okay, phi. For calculating, here we tell about that the angular distribution is equal to 1 by 2 into pi. That is, g of phi is equal to here f of phi, f theta is equal to 1 divided by root 2. G phi is equal to 1 divided by root 2 pi. That's the two condition. What's the value of L? 0. What's the value of M? 0. What is f of theta is equal to 1 by root pi. What is g pi is equal to, g phi is equal to 1 by root 2 into phi. Now, the angular distribution function, how can you calculate the angular distribution function? Here I have root 2, here I also have root 2. We can written as 1 by root 2 into 1 by root 2. Okay, 1 by root 2 into we can written as is equal to 2. Am I right? Is equal to 2. So we can written as 1 by 2 into pi. What's the answer? 1 by 2 into pi. This is the angular distribution function equal to, angular distribution function is equal to 1 by 2 into root 5. Okay, and it is an independent angle theta and pi, and it is an independent of angle theta and pi. Okay, now we can be say that what is the shape of an s orbital? The shape of an s orbital is spherical shape. What's the shape? Spherical. By means we can be say the shape of an s orbital. By this method we can be say the shape of s orbital is spherical, and this is only for the one word question. For the p orbital, dumbbell shape, and d orbital we are saying clover leaf shape. Clover leaf, clover leaf shape. Okay, about the d orbital. Okay, this shape, clover leaf shape, and also f orbital have a 15 proton to complete the fifth level of a tetrahedral structure. We can be given as a tetrahedral structure, that is with the fifth level of tetrahedral. Then how can we draw the S subshell. Okay, S orbital, 1s orbital, 2s orbital, 3s orbital. Like that, how can we draw the S orbital? For example, it is a spherical shape S orbital. X-axis, Y-axis, and Z-axis. This is about the X-axis. Okay. Okay. Here, imagine this is the S orbital. Here, having the center, we have the nucleus. Am I right? Nucleus. X, Y, and Z. Okay. Next about the QS orbital. What is the difference between QS orbital means? Imagine this is a first 1s orbital. Next one is a in between 1s orbital. This is 2s orbital. In between 1s orbital and 2s orbital having some gap, some space. Otherwise, you can take like that. Okay. This we are saying that nodal surface. So otherwise we can use nodes. Nodes. Okay. Here 2s orbital having only one nodes. Okay, having only one nodes. Clear? About the that is a. What about the 3s orbital? 1, 2. Okay, this is 2s, this is 3s. How much nodes they are having? This is one node, this is another node. So how much nodes they are having? 2 nodes. How much nodes? 2 nodes. Okay. These are the small things. We can easily learn about the nodes. Okay. Here next about what are the different 3 orientation possible of, already I told you, possible of 2p subshell. What are the 3 possible orientation? Okay, what are the 3 possible orientation for the 2p subshell? 2p subshell, tell me what are the 3 possible orientation? One is 2px, another one is a 2py, another one is a 2pz. Can you say which are the values is given to 2px, 2py, 2pz? You are giving -1, 0, +1. Here, -1, 0, +1. Okay, 2p have only one nodal surface. So 2p will have which shape? Dumbbell shape. Okay. For example, I am drawing the 2p subshell. This is 2px. Okay, this is x-axis, y-axis. Okay, this is the dumbbell shape, dumbbell shape. Okay, this is the lobe. What is that one? Lobe. Okay. These lobes are separated by a nodal plane, one of the nodal plane. Here, It is separated by nodal plane about the p subshell. These are all dumbbell in shape. Okay, 2px like that. If it is present on the x-axis, we are saying 2px. Suppose these two lobes are present in y-axis, means 2py. Suppose it is present on the z-axis, means 2pz. Here, 2pz like that. Now it is present in x, so we are saying 2px. Suppose present in y means 2py. Suppose present in 2pz means 2pz. Yeah. All diagram having in your textbook, please look and learn. Okay, you can try it. Take return practice. Next about the D subshell. What are about the D subshell? I already told you that D subshell. D subshell. Which are the orientation for D subshell? D, X, Y, Z. First one, D, X, Y. Next one, D, X, Z. D into X into Z. D, X, Z. Next, D, Y, Z. D, Y, Z. Next one, D, X square minus Y square. D, X square minus Y square. Next one, D, Z square. Okay. These are the 5 orientation of D subshell. Clear? Can you give the values? Start with -2, -1, 0, +1, +2. These are the values is given from D. D here value L is equal to 2. L is equal to 2. And M is equal to M values are. Which are the M values? -2, -1, 0, +1, +2. These are all M value. Okay? Then 5D orbitals. M values given 5D orbitals. These are the 5D orbitals. dxy, dxz, dyz, dx square minus y square, and dz square. Please all of you take the book and learn that one. That how to draw the diagram. Just only for learning. Okay. Please draw it. Next one about the F subshell. Okay. Already I told you that which are the F subshell. Which are the F subshell? Already I told you. Can you remember which are the F subshell? One is what? F Z. You should be write small letter. F Z cube. Okay. F Z cube. Next one. F X Z cube square. Third one. F Y Z square. Fourth one. F X Y Z. Fifth one. F Z X square minus Y square. Next sixth one. F X X square minus 3Y square. Sixth one. F Y 3x square minus y square. These are the summon orientation. F Z cube, F X Z square, F Y Z square, F X Y Z, F Z x square minus y square, F X square minus 3y square, F Y 3x square minus y square. Okay, these are the 7 orientation. These are the 7 orientation. And here the values, which are the values we are giving for F. Here L, the value of L is equal to, that is azimuthal coordinate number is 3. Then the possible M values, what are the M values for the F subshell means? Here start with -3, -2, -1, 0, +1, +2 and +3. Okay? Okay, for anyhow, today assignment, draw the shape of 1s orbital, 2s orbital and 3s orbital. It is in page number 49. Next one, draw the shape of 2p orbitals. This is the page number also 49. Draw the shape of 3d orbitals. That is the page number 49 and 50. Draw the shape of f orbital. That is the page number 50.
only the shape is enough. Don't write the line also. You should be draw. At least how to draw, you should be take practice. For any doubt, you can be call me. Don't write anything others. Only drawing the shape of the orbitals. Okay? Don't waste your time. Simply you should be draw. Okay? Don't waste your time. Within 10 minutes, you should be finished this all the orbitals. Okay? So do it. Thank you all of you. Thank you. Have a nice day.